These are my co-authors of this paper, Madhukumar SD, Kalyan Kumar and Suresh Chandra Moharana. This is the outline of my presentation. First I'll give you an introduction about what is cloud computing. Next I'll tell about what is the motivation behind this paper and the problem statement that we are going to address in this paper, and we'll discuss about the solution using our proposed methodology. Finally, we'll give the conclusion and future directions. Introduction. Cloud computing is basically, as many of you know, is an internet-based computing that it provides shared pool of resources on demand. It has the following features like pay-per-use, infrastructure sharing, scalability and availability, security, device and location independence, and many more. It provides everything as a service in a pay-per-use model. So in these clouds, there are many kinds of resources like storage, CPU allocation, and everything. So we need to allocate the resources in a very efficient manner. So users will use these clouds for many of the purposes like they'll submit their job and they want to complete this job within certain amount of time, and also they can host their applications in the cloud. So these applications will utilize the resources based on the load that they'll get. So this load is very dynamic that we can't predict. So in order to provide the resources in an efficient manner, we need efficient resource allocation mechanisms. So the main motivation behind this project is that these cloud applications are increasing very rapidly, and the data center energy consumption and operation costs are growing. So, but most of the approaches have tried to satisfy the QoS of the customers without considering the energy footprint. In this paper, so we are trying to provide a solution that optimizes the power consumption of the data center resources. This is the main problem statement that we are going to address in this paper. We are trying to develop an adaptive resource allocation for clouds using the ant colony framework by satisfying the QoS requirements of the customers, and these QoS requirements are specifically throughput and response time. This is the proposed architecture of this solution. First, the clients will submit the request to the controller node, and whenever we are thinking of a resource allocation, we need to do many of the things like first we have to allocate the request to some of the node, and we have to take the load balancing, and also we need to take care of what are the available nodes and unavailable nodes, etc. All these functionalities will be done by some of the ant agents in this ant colony mechanism like scouts, testers, cleaners, and worker ants. And this queen ant will maintain the available resource table, which acts as a central repository that stores the information about all the nodes in this cloud. First, we will gather the resource consumption and resource capacity and power consumption of all the nodes in the servers, and we will sort them in the descending order of the processing power per watt and memory consumption per watt. We will store this information in the available nodes list shown in the previous figure. Now, we will discuss about the functionalities of different ant agents. As I have said earlier, the controller node in the cloud acts as a queen. It generates the testers, scouts, cleaners, and workers periodically, and it maintains the available nodes list. The tester ant is responsible for gathering the resource utilization, power consumption, and it makes the load balancing decisions. The scout ant is responsible for gathering the newly added nodes in the cloud and updating this information in the available nodes information. And the worker ant is responsible for accepting or rejecting the service requests given by the customers to the controller node. Finally, this cleaner ant removes the unavailable nodes information from the available resource table. So, in all of these functionalities, some of these ants needs to be moved from one node to another node to get the resource utilization and also to make the load balancing decisions. So this queen ant and worker ant will be maintaining the available resource table, but rest of them will have to move. So each node in the cloud maintains a list of neighboring nodes. Whenever an ant reaches a node, it updates the controller about what is the information gathered by that ant, and then it will randomly chooses an unvisited neighboring node. When all the nodes are covered, it makes the visited node list empty, and it continues again in the same way. So specifically, worker ant will always be looking in the queue of service requests, which will be stored by queen ant given by the customers, and it will check for any pending requests in the queue. If there are any pending requests, it will dequeue one of the requests, and it will try to allocate the service request to a VM in a power efficient node. If it is not possible, it moves to the next node that is pointed by allocation pointer, and then it will try to allocate. If there are no node available, then it will send an alert to the administrator that the resources are very few. It creates a VM with a specific processing power and memory. So basically, up to now what we have done is the customer's service request is deployed in customer's application is deployed in a virtual machine. Now we have to monitor this performance of this application. So this SLA monitor agent will be calculating the average response time and throughput of this application, and it informs continuously to the hypervisor about the status of this application, that is whether this application is using how much resources like CPU and memory. So depending upon that, it will send the SLAM value, which is either 0 or 1 or 2. 0 means that the load on the application is very less, so there is no need for load balancing. 1 means that recommended for load balancing, the load is very moderate. In this 1 migrate and 1 to clone, that means that when we migrate this VM to a lightly loaded node, the throughput might be increased, but the response time still remains, because the service request will be staying in the queue itself, but the response time will not increase. But if you clone this VM and host this and if you share this traffic among these two VMs, the response time will be decreased. That's why we have two options like migrating and cloning. And 2 means that strictly needed, the load is very high, we have to balance load at any cost. These are some of the parameters like response time. These are tunable parameters, we can change that. Now the tester ant gets the resource utilization and power consumption information on the visited node, and it informs this information to the available nodes list, and also it makes the load balancing decisions. Here we are considering that 80% of the CPU and memory utilization is considered as a normal situation, and if it is at 90% or more than 90%, then we are considering it as a peak situation. So depending upon this utilization information and SLAM value that is gathered by this tester ant, it makes the load balancing decisions. And also if the utilization of certain node is less than 50%, then it means that it is very lightly loaded, so we can move all these VMs in this node to some of the nodes that are power efficient above this node in the available nodes list, so that this node can be power off and the power consumption of the nodes is reduced. Now this scout ant, as I have said earlier, it discovers the newly added nodes in the cloud. The discovery can be done in the following way. That means through node registration. And the newly added node will be trying to send a request for joining to any of the nodes in the cloud, and whenever the scout ant reaches that node and it finds a request, it will register this newly added node and updates this information in the available nodes list. In case of resource scarcity, during worker ant resource allocation, the controller node will do this registration for adding the new nodes. Cleaner ant, it detects the failed or unavailable nodes in the cloud, and it removes this information from the available nodes list. It also sends this information, sends alert to the user before the service time is completed, so that the agreement can be renewed. And also it removes the VMs whose service agreement time is over, and removes the cloned VMs when the load on the application is very less. Finally, what we are going to conclude here is that we have presented an energy efficient mechanism for resource allocation of cloud applications, and we have modeled this proposed methodology using ant colony framework. and we are going to implement this mechanism using CloudSIM toolkit, and the performance evaluation is in progress. These are some of the future directions. When we try to use this or apply this mechanism on a real cloud environment, we can incorporate this load prediction and usage models so that it will be very realistic, and also our approach is very flexible and can be extended easily to incorporate new functionalities, because we have modeled the solution modules as independent intelligent ant agents, so we can incorporate new features also here. These are some of the references. Thank you. For any queries, please feel free to ask me any queries here. I am giving you my email ID, siva.chimkut@gmail.com. Thank you.